So next we're going to talk about inverse of a 3 by 3 matrix. So that's the general format of a 3 by 3 matrix. So here we're told to the left that the adjoint is the transpose of the matrix of cofactors, and A inverse is 1 over the determinant of A times adjoint A. Now adjoint A, ADJ A, which is the adjoint of A, is the matrix, is the transpose of the matrix of cofactors. All right, so let's get into it. So to find the inverse, one of the first thing we need is we need the determinant. So let's just write it again. A inverse is equal to 1 over the determinant of A times adjoint A. So let's find the determinant. The determinant of A is 1. The determinant of 2, 1, 2, minus 1, and then minus 0. The determinant of 2, 1, 1, minus 1, plus minus 1, the determinant of 2, 2, 1, 2. So this is 1 minus 2 minus 2. This is going to come out to be 0. A positive times a negative is a negative. 4 minus 2. So this is minus 4 here. This is minus 2. The determinant is minus 6. So we need the determinant. The next thing we need is adjoint A. But before we can get adjoint A, we have to get the matrix of cofactor. And to get the matrix of cofactor, we need the cofactor of every element in the matrix A. So let's get the cofactor. First row. First element, first row. All right, second row. Third row. All right, so the sign convention, positive, negative, positive. The determinant of 2, 1, 2, minus 1. We ignore the elements in the first row and the first column and find the determinant of the matrix formed by the elements that remain. And so the determinant would be minus 2, which is minus 4. Second row, first element, first row, second element. So we're ignoring here. So this is 2, 1, 1, minus 1. Negative sign convention. So this is minus 2, minus 1. This is positive 3. All right, so the next one is 2, 2, 1, 2. This is 4 minus 2. This is 2. Third row, or second row, sign convention, negative, positive, negative, 0, minus 1, 2, minus 1, minus 0, minus, minus 2, minus 2. Second row, second element, 1, minus 1, 1, minus 1. We'll just click with 0. This is minus 1, minus, minus 1. Looks like 0. Third element, second row, 1, 1, 0, 2. Minus 2, minus 0, minus 2. Last row, 0, 2, minus 1, 1. Sign convention, zero, 2, minus 1. This is 0, minus, minus 2. This is 2. One, 2, minus 1, 1. Sign convention, negative, 1, minus, minus 2, minus 3. And last, 1, 2, 0, 2. This is 2, minus 0. This is 2. So the matrix of cofactors would be minus 4, 3, 2, minus 2, 0, minus 2, 2, minus 3, 2. That's a matrix of cofactors. Then we need to find adjoint A. Now, adjoint A is equal to the transpose of the matrix of cofactors. Now, the transpose simply means that you interchange the rows and the column. So the first row becomes the first column. So this is minus 4, 3, 2. The second row becomes the second column. And the third row becomes the third column. So this would be adjoint A. And so A inverse would be 1 over the determinant of A, which is minus 6, times adjoint A, which is the transpose of the matrix of cofactor.
You get 96 is
All right, so here is 3, 0, minus 3, 2, minus 2, 2. Now, if I want, I could take it a step further to being minus 4 over minus 6, minus 2 over minus 6, 2 over minus 6, 3 over minus 6, 0 over minus 6, minus 3 over minus 6, 2 over minus 6, minus 2 over minus 6, 2 over 6, and take it down to A inverse is equal to 2/3, 1/3, minus 1/3, minus a half, 0, a half, minus 1/3, minus, sorry, not minus, just 1/3, and 1/3. All right, so just making a minor correction here, this should be negative, and so this should be negative 1/3. All right, so example 38. In example 38, we're asked to find the inverse of matrix A, and A inverse is 1 over the determinant of A times adjoint A. So let's start by finding the determinant. The determinant of A is 3 minus 1 plus 1 so this becomes 3, 2 minus 0, 1, 4 minus 2, 1, 0 minus 2. This is 6 minus 2 minus 2. The determinant is 2. Next, we need the matrix of cofactor. To get the matrix of cofactor, I need to find the cofactor of every element in the matrix. First row, sign convention, positive, negative, positive. Second row, third row, this is negative, positive, negative, sign convention. And for the last row, it's positive, negative, positive. This is 2, 2, 0, 1. This is 2 minus 0, which is 2. Minus, sorry, already there. 4, 1, 2, 1. Minus 4 minus 2, which is minus 2. 4, 1, 2, 0. This is 0, minus 2, minus 2. Second row. Minus 1, 1, 0, 1. Minus 1 minus 0, minus 1. 3, 1, 1, 1. This is 3 minus 1. This is 2. Minus 3, 1, 0, 1. Sorry. 3, 1, 1, 0. This is minus 0 minus 1. So this becomes 1. One, 2, 1, 2. This is 2 minus 2. We have 0. 3, 4, 1, 2. Minus 6 minus 4 minus 2. And lastly, 3, 4, 1, 2. This is 6 minus 4. This is 2. So what we have next is the matrix of cofactors. And the matrix of cofactors would be 2 minus 2 minus 2 minus 1, 2, 1, 0 minus 2, 2. Then A inverse is 1 over the determinant of A, which is 2, times A adjoint. And A adjoint is the transpose of the matrix of cofactor. The transpose means that you're going to interchange rows and columns. So the first row becomes the first column. And finally, carrying it a step further, we get A inverse is equal to 1 minus a half, 0, minus 1, 1, minus 1, minus 1, a half, 1. All right, so here we're starting off by looking at the properties of inverse. So the properties of inverse are the inverse of A inverse is equal to A. The inverse of AB is equal to B inverse, A inverse, the product of B inverse, the product B inverse, A inverse, and A inverse times A is equal to A times A inverse, which is equal to I. In other words, if you multiply a matrix and its inverse, you're going to get the I matrix.